Welcome to this explainer. Okay, today we're taking a super methodical approach to solving literally one of your worst development nightmares, the unreproducible bug. We're going to master your network traffic using a seriously powerful tool called Charles Proxy. Let's turn those invisible bugs into easily fixable problems. So picture this. You're staring at a user report of a critical failure. The ticket says the app crashes completely when trying to load a specific page. But when you fire up your local dev environment or test it on your own machine, everything works perfectly, not a single error in sight. It only happens in production, and you just cannot reproduce it locally. What do you do now? I mean, you can't fix what you can't see, right? Well, it's the classic crime scene in software development. The culprit? Usually a specific, highly elusive API response value that only triggers out in the wild, leaving absolutely no local trace. Maybe it's a null value or an array should be, or some bizarre string of characters from a legacy database. Whatever it is, your front-end code is choking on it. And because it's a super rare edge case, your standard staging API never returns this value. So you're essentially flying blind. Enter your magnifying glass, Charles Proxy. So what is it? Charles is an application layer man-in-the-middle, or MITM, HTTP and HTTPS proxy. Basically, that means it sits directly between your app and the internet. It acts as a bridge. So instead of your app talking directly to the server, it talks to Charles, and Charles talks to the server. Running this, even if you're just using the trial version on macOS, gives you total transparent visibility. You can decrypt, inspect, and most importantly, modify every single piece of data traveling back and forth. All right, let's dive into Method 1, intercepting traffic with the rewrite tool. While Charles is awesome for passive observation, the rewrite tool literally lets you play God with your data. You simply map your target, let's say we're using a public test API like JSON placeholder, and create a rule. So you'll go to Tools, select Rewrite, add your target URL, and then add a rule. For our first trick, let's target a successful response status and tell Charles to just hijack it. Instantly, this before and after reveals exactly what happens. On the left, we see what the server actually sent, a totally successful 200 OK status. But on the right, that's what your application actually receives, a devastating 500 internal server error. We've swapped this out without touching a single line of backend code. Oh, and here's a quick pro tip straight from the Charles documentation. When you rewrite a status code, you actually have to include the message too. So you write 500 internal server error matching their specific regex format. If you don't do that, the client might not parse it properly. Okay, now let's step it up and inject some targeted chaos into the mix, step by step. We need to intentionally test your app for graceful failure. We can actually orchestrate a full stress test using a few different techniques. We just talked about forging status codes like 404s and 500s, but we can also mutate the actual JSON data bodies using regular expressions. And we can even add artificial latency. Charles has this amazing throttling tool that lets you simulate, say, a terrible 2G cellular network, dialing your bandwidth way down to 256 kilobits per second and injecting 300 milliseconds of latency. It is literally the perfect way to test those loading spinners. So how do we modify the JSON data? We target the body of the response, we set the rule type to body, check response, and then use a super simple regular expression, just brackets with a \S and capital S. This captures the entire incoming payload. Then, in the replace field, we simply drop in an empty array. The transformation here is absolute. A robust, perfectly formatted JSON payload from your API is intercepted, scrubbed, and replaced completely by an empty array. You've just simulated catastrophic data loss right on your local machine to see how your app handles it. Now, if your app expects an object and gets an empty array, it's probably going to crash. But now, you can reproduce that crash, debug it, and fix your code to actually handle empty data safely. Moving on to Method 2. Faking APIs entirely with the map local feature. Sometimes rewriting rules is just a bit too tedious, or maybe the development API is completely offline. Well, map local literally cuts the cord to the internet. Charles transparently intercepts the remote API call, but instead of forwarding it to the server, it serves a custom JSON file directly from your computer's hard drive. Your app has absolutely no idea it's talking to a text file on your desktop instead of a server in the cloud. How cool is that? This technique is incredibly versatile. It's perfect for offline testing, like if you're working on a plane or during an unexpected outage. You can simulate massive payload sizes by just saving a giant JSON file directly to your drive. It's also highly strategic for mocking expensive third-party APIs. Think about it. If you're building an integration with a paid service, you definitely don't want to rack up usage costs or pollute their production analytics with your local testing. MapLocal prevents that entirely. Let's look at a real-world case study, the broken payment flow. So here's the scenario. A user reports that their checkout process just freezes entirely, but it only happens occasionally. After digging into your server logs, you realize the flow breaks completely only when the Payment Gateway API returns a very rare payment_declined error code. The problem? QA cannot easily trigger this code natively because test credit cards usually just return success, so you're stuck. But armed with Charles Proxy, look at how fast the timeline shifts here. Minute 1, the bug is reported. Minute 3, our engineer opens Charles, sets up a rewrite rule targeting that checkout API, and forces it to return that elusive payment_declined string. Minute 5, the engineer clicks checkout in their local app, the rewrite rule fires, and boom, the app crashes live, right on their screen. By minute 8, a forensic-level bug report is filed, complete with the exact network logs and the specific line of code that failed. A completely unreproducible bug solved in under 10 minutes. As the source documentation perfectly highlights, this tool turns guesswork into a precise, evidence-based debugging process. You no longer have to shrug your shoulders and say, well, it works on my machine. You can actually make your machine simulate the exact chaotic environment of the real world. You control the network narrative. We've seen how to intercept traffic, rewrite status codes, inject latency, mutate JSON with regex, and mock entire servers using MapLocal. You now literally possess the power to see the unseen and test the untestable. So I'll leave you with this final thought. Now that you understand how to control the network, what impossible, elusive bug will you hunt down and solve next?